I have incorporated the laws of physics with electrical engineering, and this is one example. See this rod here? I marked it here red. It doesn't matter how much force I apply, it's not going to rotate. The reason why, it doesn't have moment of inertia. But see, this one is at least 2 centimeters more, or in other words, 2 centimeters after the axis of rotation. So in other words, it's 4.5 centimeters. So you can see, it doesn't matter how hard I try, there's no way I can apply any force on this because it doesn't have moment of inertia. But when I change this, you see what happened. This rotor has moment of inertia. The reason why, the mass is distributed around the axis of rotation at least 2 inches on each side. See? I apply the same force, but you see what happened. You see what happened? It rotates at least 6-7 minutes, 6-7 seconds. The reason why, it has moment of inertia, and immediately when you turn this, and then the kinetic energy comes in. Now I have to explain how the simple electric motor works. This was in 1956, and I was only 2nd grade, and I remember I did this for my science professor or science teacher. He loved it, and finally I had to make 2 or 3 for him and give him free. But see, this is amazing. This electric motor, you can see, is 180 degrees on one side, 180 degrees on the other side. Let me go ahead and turn it on, and you can see even this simple electric motor can go 2,750 RPMs. The reason why it's not that fast, because you see this? This is using the old system, commutators. It has to rotate 180 degrees, and it reversing the current from positive to negative until attraction becomes a repulsion, and repulsion becomes attraction. Now, I'll show you this. This one I didn't put the connector, I have to hold it by hand, but overall it's a good electric motor, and like I said, the shortcoming is it has to rotate 180 degrees on one side, and then it's changing or reversing the current to the other side. They're rotating real good, and then when I check with my laser beam, it's going 2,750 RPM. Well, of course, the bad thing about this is it doesn't have a lot of moment of inertia because the whole rotor is almost like 60 grams, but this one is 350 grams. And when it comes to kinetic energy, that makes a big difference. I had to take one apart so you can see. See, this is the commutator. Well, of course, it's not in real good shape because I couldn't find a real good copper. See, this is rotating 180 degrees, and this part is energized, and then it's changing, this part is energized. You see, the precision is not 100%, but still it works. And guess what? Everything is recycled material. And this is the stator, that's the rotor. And you can see every time it rotates here, attraction becomes repulsion, and the repulsion becomes attraction. And this was another one. I was also 8 years old. I built this for my science teacher. And this one is using permanent magnet. And amazingly, this is exact replica in 1956. I mean, I was 8 years old. I was second grade. But see, this one is using north and south on each side. This is the same principle. It's a DC motor with commutator, and then you can see every 100 degree is changing rotation, reversing the part. Let's see.